You take a bite of a dish you have known for decades. The recipe is unchanged, yet something feels missing. The sweetness seems quieter, the aroma arrives late, or a familiar ingredient suddenly stands out. The food has not necessarily changed. The sensory system building its flavor may have. That raises a deceptively simple question. Why can familiar foods taste different as you grow older? The first clue is that taste and flavor are not the same thing. Taste is the set of basic signals detected mainly by sensory cells in your mouth. These signals include sweet, salty, sour, bitter, and umami, the savory quality found in foods such as broth, meat, mushrooms, and aged cheese. Flavor is much larger. It combines taste with aroma, temperature, texture, touch, and chemical sensations, such as the cooling of mint or the heat of chili. When you chew a piece of fruit, molecules dissolve in saliva and reach taste cells, grouped within taste buds. Those cells convert chemical contact into electrical messages. Several cranial nerves then carry the information toward the brain. At the same time, volatile aroma molecules travel from the back of the mouth into the nasal cavity. This pathway is called retronasal smell. It is the reason a blocked nose can make coffee, soup, or chocolate seem strangely empty, even though the tongue can still detect sweetness, saltiness, bitterness, or acidity. Your brain receives all of these signals and assembles them into one experience. The crispness of an apple, its cool temperature, its sweetness, its acidity, and its aroma are not experienced as separate reports. They are blended into the single perception called apple flavor. This is the first counterintuitive part of the mystery. A food can seem to have lost its taste even when the largest change has occurred in smell. The National Institute on Deafness and Other Communication Disorders notes that true complete taste loss is rare. Many people who report losing taste are actually experiencing a smell problem. That distinction matters because the aroma of food contributes much of its identity. Without enough retronasal aroma, a pear and an apple may still seem sweet and slightly acidic, yet the qualities that clearly separate them become much harder to recognize. Age can influence both systems, but it does not affect every person or every taste in the same way. For many years, the explanation was often reduced to a single idea. You grow older, you lose taste buds, and food becomes bland. Modern research presents a more complicated picture. Taste buds contain cells that are regularly renewed, and the aging process may affect their number, structure, blood supply, receptor function, and capacity for renewal. Yet changes in the tongue alone cannot explain the full experience. Saliva, smell, oral touch, nerves, medications, dental health, and the brain all contribute. A major systematic review published in 2024 by Larissa Alves and colleagues compared taste sensitivity in younger and older adults. The review included 18 observational studies, with more than 1,000 older participants and more than 1,600 younger adults. On average, older adults needed stronger concentrations to distinguish some tastes. The clearest group differences appeared for sweet, salty, and umami. The combined analysis did not find the same clear difference for sour and bitter. That does not mean sour and bitter never change. It means the research is not uniform. Studies use different liquids, taste strips, concentrations, age groups, and testing methods. Some measure the weakest signal a person can detect. Others measure whether a taste can be correctly named. Still others ask how intense or pleasant a real food seems. These are related questions, but they are not identical. A laboratory test may show that a person needs a slightly stronger salt solution to identify saltiness. That does not automatically tell you whether the person will enjoy soup less, add more salt, or change long-established food preferences. Sensitivity, enjoyment, habit, culture, memory, and expectation interact, but they do not move together in a simple line. This helps explain why two people of the same age can experience the same meal very differently. In 2022, Tobias Braun and colleagues tested oral sensitivity, taste, and smell in 30 younger adults and 30 adults over 60. The older group performed less well, on average, in all three areas. The study was small, so it cannot describe every older adult, but it demonstrates an important principle. Several sensory channels can change together. What feels like one fading flavor may reflect several modest changes occurring at the same time. Saliva is one of the least noticed parts of this system. Before a food molecule can activate many taste receptors, it must dissolve and move through the fluid coating the mouth. Saliva also lubricates food, influences texture, helps release aroma compounds, and supports oral tissues. Research by Xiaobing Huang, Yichen Guo, and Yongsheng Wei found that age and dry mouth were important predictors of gustatory function in healthy adults. This does not mean that aging automatically causes severe dry mouth. The relationship is influenced by hydration, oral health, illness, and medication use. Many medicines can reduce salivary flow or produce an altered, bitter, metallic, or persistent taste. The effect varies greatly between individuals. This is why a meal may taste normal for years and then seem different after a change in health, dental condition, or medication. The calendar may be involved, but age is not always the direct cause. The mouth itself also changes. Teeth, gums, chewing ability, dentures, tongue movement, and the condition of the oral lining can alter how food is broken apart and spread across sensory surfaces. If chewing releases fewer aroma molecules, less aroma reaches the nose from behind the palate. If the mouth feels dry, a cracker may seem rougher, and a piece of meat may require more effort. Texture then becomes part of the altered flavor experience. Smell may create an even larger change. Olfactory receptor neurons high inside the nasal cavity detect airborne molecules. Their signals travel to brain regions involved in identification, emotion, and memory. Smell often becomes less sensitive with age, although the pattern varies. One person may notice coffee becoming weaker. Another may still smell coffee clearly, but lose sensitivity to flowers, herbs, or certain cooked foods. The loss is not always obvious, because it can develop gradually. The brain adapts to the information it receives. A slow reduction may feel less like a sense disappearing and more like recipes becoming dull, fruit becoming less fragrant, or restaurant food becoming less distinctive. Then there is the brain itself. Taste messages do not end at the tongue. They are processed through brainstem pathways and then through regions involved in sensory awareness, reward, memory, and decision-making. Research reviewed by Chia, Shayna Yeager, and Josephine Egan suggests that age-related changes can occur at several levels, from taste bud biology to central processing. The result is not simply a weaker signal. The balance among sensation, reward, expectation, and appetite may also shift. A familiar dish carries a history. Its flavor includes what you expect it to taste like, where you usually eat it, and the memories attached to it. The brain compares the incoming sensory pattern with a stored pattern built over years. When the new signal is slightly weaker or differently balanced, the mismatch becomes noticeable. You may describe it by saying, "The recipe is not what it used to be," even when every ingredient has remained the same. The reverse can also happen. A food once disliked may become acceptable because bitterness feels less intense, because experience has changed expectations, or because a new context gives the food a different meaning. Sensory aging is therefore not only a story of loss, it can also be a story of altered balance. Valentina Ponzo and colleagues reviewed the question of whether age-related taste impairment exists even in otherwise healthy older adults. Their 2024 review concluded that it does appear to exist, but the effect is highly variable, and its influence on actual food choice may be modest compared with cultural, psychological, and social factors. That is an important limitation. A laboratory can measure taste thresholds, but a meal is eaten in a life, not in a laboratory. Company, mood, appetite, cooking skill, food temperature, visual appearance, and personal history can all influence how satisfying food feels. A favorite meal shared with family may remain deeply enjoyable even if one sensory channel has become less sensitive. Another meal may feel disappointing because its aroma, texture, and expectation no longer align. There is also no single age at which food suddenly changes. The process is gradual for many people and minimal for others. Genetics, smoking history, oral health, infections, medical conditions, environmental exposure, and medicines can all contribute. Even within one person, sweet, salty, bitter, sour, and umami may not change at the same rate. This unevenness explains why simply making every food stronger is not a complete answer. Adding more salt or sugar may increase one signal while leaving aroma, texture, or dryness unchanged. Variation in temperature, texture, color, and natural aroma can sometimes make a meal more noticeable without depending on only one basic taste. The goal is not to overpower the senses, but to understand that flavor is built from several channels. A gradual change in flavor can be part of normal aging, but a new, sudden, severe, persistent, or worsening change should not automatically be blamed on age. Infections, dental problems, medication effects, nutritional deficiencies, and other medical conditions can also affect taste or smell. A qualified health professional can assess the pattern. Medication should never be stopped or changed without professional guidance. Now return to that familiar dish. The sweetness may be quieter because the taste threshold has shifted. The aroma may be weaker because fewer odor molecules are being detected. The texture may feel different because saliva and oral sensation have changed. The pleasure may arrive differently because the brain is combining the signals through a lifetime of expectation and memory. The recipe can remain exactly the same, while the experience changes. Flavor is not stored inside food as a finished object. It is reconstructed each time you eat, by your tongue, nose, mouth, nerves, and brain. As those systems change at different speeds, even the most familiar meal can become a slightly different version of itself.